I need those subscribers, right? All right, there we go. That's your deck of cards in a nutshell. So now I'm going to ask you to answer, and you don't have to copy any of this down. You just answer, right? Consider a standard deck of cards. So you're just going to go 1A, 1B, right? Like what's the probability of drawing a spade? Probability, write it down. I want you to write it down in 3 formats, right? Fraction, decimal, percent. So for every single one, you're going to have fraction, right? Decimal, and percent. Right? And I will be adding as you're copying. So I can probably zoom in a little bit more. Well, this is probably it actually. If you can't see it, just maybe move up a bit. Lots of room up front here. Yeah. No simplifying. Nope. No simplifying. I don't want to deal with that right now. So A, B, C, D, E. Good morning. Just grab a piece of loose leaf and answer these questions. Right, so I would do ace, 2 to 10, jack, queen, king. If this is too tedious for you, you can just say, I don't want the update, right? And that's fine. But then, right, isn't it, it's a lot easier to see, oh, there's 4 kings, 4 queens, 4 jacks, 4 tens, and so forth. Okay, so that's the update. That's the best I can give you. I think that'll be the final version of the of this cheat sheet entry. Got it? Okay. Let's answer this. We'll do it on a piece of loose leaf here. Right, so follow along. We're going to go, each one is going to be worth 1 for now, okay? So for 1A, spades, how many spades are there? There are 13, right? It's a full suit out of 52. And I'm going to have to do this live because I just made up, right? So that's, I knew it was 25, trust me. But sometimes I don't think, right? 25%, 1 and 4 would be a spade, okay? Then, yeah. 1 over 4, yeah, that's fine. Oh, that's even better. B, a red 7. How many red 7s do you have? You go here, you go into the red zone. So these two are reds, right? So if you want to kind of cut it there, right? And a 7, there'll be 2 red 7s here. So we've got 2 out of 52. And that is 0.0385 or 3.85%. Okay. If you made a mistake in getting your decimal, take off half a mark. Okay. That's how we're going to roll today. C, a black queen. How many queens, right? You got to look at your study sheet. You go into this branch and, right, there'll be 2 of them. So it's actually the exact same answer. So you can kind of speed up that process, right? If you did that right, it's the same. Okay. Ace, drawing an ace. Again, there are 4 aces. It doesn't specify what color. So it's just 4 out of 52. And that would be 0.0769 or 7.69% chance of drawing that. So 1, 1, 1 so far, okay? E. Okay, let me just bring E up here. What are the chances of not getting a 9? Of not getting a 9. So I want you to think this way. Probability of getting a 9 would be 4 out of 52, correct? So just get the probability of not getting a 9 would just be what's left over, right? 48 out of 52. This is the answer I'm looking for, 48 out of 52. So that would be 0.9231 or 92.31%. So it's not 4 out of 52, it's not that, right? So how did I get the 48? I just go total minus the 4 to get that, okay? F, king of spades. How many king of spades? Well, you're very specific. It's not just a black card, it's actually spades. There's only 1. There's only 1, okay? So it's 1 out of 52. 1 out of 52 on the calculator gives me 0.0192, which is 1.92%. Very small chance of getting that one out of, right, randomly selecting. G, diamond, a diamond face card. So I'm really testing your knowledge here, right? So pardon me here, but I'm gonna go straight to diamonds. How many face cards are there in the diamond category? Just 3. So 3 out of 52. That is 0.0577, which is 5.77. Sorry, 5.77%. Okay. So we have 7 marks allocated to this question. Okay, 7 marks there allocated to this part right here. Okay. Capiche? Let's keep going. Question 2. And I will do more of these, so don't, like, if you bombed it today, I hope not, but it does happen from time to time. you get to give it another go next time, and the next time, and the next. Can I say something that isn't being said? You have to be very, very aware of that. Every time we go to the next question, we're putting the card back. You understand that part? Right? You always put it back. So you always start with 52, and you start with 52. Later on, it's going to be like, I draw one, like Lauren takes it. I'm going to draw one now. How many are left? 51, right? I draw one, and Alicia takes another one. Now there's only 50, right? So we will get to the point where you don't put them back, right? So keep that in mind. Next question. And here I'm curious to see what you did, okay? Very curious to see. So this is where I'm putting theoretical and experimental side by side, okay? So state the experimental probability of drawing a yellow. Yes, you got to go by the results. There's 40 instances out of the 250. I already told you that it's 250, but if I didn't, you would have to add up these four values, and that adds up to 250. So we've got that. Of course, you can. This is easy to reduce, folks. Cancel the trailing zeros. You didn't have to. I know I didn't say that, but that would have been a very easy one to do. Divide both of them by 10, basically. And so you get 0.16, which is 16%. Okay? So 1 mark for that one. Yeah. That's fine. 40 out of 250, you get the mark. Yeah. I didn't say simplify, right? When you see that word, which is going to start happening, I don't want to deal with that right now. I want you to understand probability. The simplifying is I can deal with later, right? B, I have to repair what your grade 9 teachers didn't, or maybe even earlier. Fractions started way earlier. State the theoretical probability of drawing a yellow, and that's where you don't look at the experiments. You just look at the spinner. There are 4 options, right? And how many of them would be yellow? Just 1. So it's 1 out of 4, which is 0.25, which is 25%. So the theoretical and the experimental are not the same. Okay? They're not the same. So 1 mark for this and 1 mark for that if you did it all correctly. Does that make sense, the difference? I hope it does after today. So when it's theoretical, forget about the results. Look at the game, right? The spinner could have 8 sections. Yellow could have shown up more than once, by the way. Then you have to go, right? 2 out of 4, whatever. Yeah. For B, no. It's just your probability. So just remember the yellow could show up again somewhere. So you just got to add up your yellows, right? And then out of the total. Like remember the star question yesterday with a spinner? There were 3 stars out of 10. 3 out of 10 in that case is the theoretical probability of getting a star. Okay. So just look at the game itself. Now C. I want to see how you did that one. When you make a prediction, which probability should you be using to make a prediction? What would make more sense? Technically, yeah, Marcy? B? Yes. You should be using the theoretical, right? When you're flipping it, always think back to the coin. You would go 50-50, right? That's the way you should be predicting. So when you have a choice, always use the theoretical, okay? So it's 1/4 times 2,500. And that's 625 times. So this is how I will mark this one. It's going to be out of 2. 1 mark for the correct probability. So if you pick the wrong one, you don't get that mark, right? You get 2 marks if you actually got 625. Okay, yeah. You basically are doing what I did. It's 1 divided by 4, which is 0.25 times this. or this divided by, like if you go 1 times this, it's 2500 divided by 4, same thing. Okay, so what are we at? 4 and 7, that's 11. I'm gonna just put the 2 here. 1 and 1 and 7. That gives us 11 total. So name and last name, make sure your name and last name is at the top. Flip it upside down, pass it forward, then get your notes. 156. 156. Yeah. One 156. And make sure you have your study sheet. All right. Run. Okay, so I hope this was a fun little AC. I just made it up, so sometimes I roll like that, right? When I think that I need to test certain things before we move on. So B and C are still based on the spinner before, so let's just answer that real quick. So my book is falling apart, I don't know why. But this, based on this spinner, on 156, it's asking what's the probability that the spinner will not stop on a heart, right? So basically what I do is probability of a heart, right? I know it's out of 10. I'm going to go figure out, right? There's one there and another one there. So there are 2 hearts there. That's not what I'm being asked for. I will do this. So make sure you write this down. Probability of not drawing a heart in this case would be what? 8, right? 8 out of 10. The best thing to do is figure out how many are there, subtract it from the total to get your, and what do these 2 add up to? 10 out of 10, which is 100%, right? So always remember that. I will show you this. 2 out of 10 is 0.2, which is 20%. So technically you could have answered this one like this, 100% minus 20%, right? Which is 80%. Like you can do it that way, like turn this into a percentage or a decimal and subtract it. And then because if they don't always ask you to state it as a fraction, right? So you decide what you want to do there. Okay. What is the probability that the spinner will stop on a square or a triangle? How many squares are there? Let's go check quick. Squares and triangles. I have 1 square and 2 triangles, right? So you just add them up. If it's or, you just add them up. 2 squares and 1 triangle. So probability of a square or a triangle would be 3 out of 10, just like that. Okay. All right. Let's keep going. I'm getting to the tougher part in a bit. I just want to fill this in so you have it. A standard 6-sided die. Make sure you know I will do 8-sided, 4-sided, 10-sided, 12-sided. Like just be aware of that. 6-sided die is tossed. What's the probability you will land on a 5? Right? You have your 1. Sorry. I will do this here. Please do the same. I will just write this out real quick. 1, 2, 3, 4, 5, and 6. Okay. The probability that it lands on a 5 would be 1 out of 6. No mystery there. Even number, your even numbers would be 2, 4, and 6, right? 2, 4, and 6 in this case. So there would be 3 out of 6. Or 1/2, right? This one I would expect you to be able to reduce 3 out of 6 into 1 out of 2. What's a multiple of 3? Multiple of 3 is multiple of anything as you start with it, and then you go up by that number. So it would be 3. What would be the next one? 6, 9, 12. That's a multiple. So these two numbers, right? Obviously, there's only 2 options here. If you're looking at the die, right? So there'll be 2 out of 6 there, which is 1 out of 3. 1 out of 3 chances to get a multiple of 3. Okay? Twelve-sided die has faces numbered 1 to 12. Of course, what are the odds, or what's the probability? Watch this. We're talking probability for the next little while. Next week, we're going to start talking odds. Everything right now is probability, so you will get so used to probability that you will think it's always probability, but it's not, right? Probability, let's just do this real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because sometimes I ask you weird questions, so it's nice to have the numbers laid out. Odd number, how many odds? 1, 2, 3, 4, 5, 6. 6 odd numbers, correct? So it's 6 out of 12, which is 1 over 2. This could have been out of a 10-sided die, right? Then you just have to be careful. The denominator will change and the numerator most likely as well. Multiple of 2, we're talking 2, 4, 6, 8, 10, 12, 14, 16. Oh, wait a minute. This doesn't apply, right? Okay. So there's 1, 2, 3, 4, 5, 6 out of 12, which happens to be 1 out of 2 as well. Okay. And now we're going to introduce a double, 2 dice at the same time. Okay. It's a probability of rolling doubles with 2 standard-sided dice. We're going to change that. Not 6-sided. We're going to make this into a 4-sided. Can you change the 6-sided into a 4-sided, please? It'll just make it easier to make the diagram. I will make you do a 6-sided in just a bit. Okay. So I will do this here with you. Okay. Please go to that second side, which is 157. There's a blank spot there, and I will try to do it without a ruler because I'm assuming most of you will not have a ruler. So then you're both in the same boat here. So what I want you to do is we're gonna write out 1, 2, leave some space in between. Right? 1, 2, 3, 4, like that. That's our first die. Right? And then we're gonna go along the column here and do the same thing here. Okay? And you do one of these. One of those. And let's try to make columns like that. So in between all the numbers, you do one of these. Okay, and then you do the same thing with the rows. There we go. So we're making, you know what this is called? An outcome table. Okay? So it's a fancy word. Let's put it on outcome table. You could make an outcome table using a combination. Let's say there's a spinner and a die. So you spin it and you roll the die, right? So let's say the spinner has red, blue, yellow, green. Then you would have red, blue, yellow, green along the left. And you would have 1, 2, 3, 4, 5, 6 perhaps. Keep in mind we're considering two four-sided die there. Okay? And I'm going to do two things here. I'm going to tell you, like, this box right here tells us that one possibility is to roll a 1 and a 1. Don't use up the whole box, right? And then this box here tells you that you could roll a 1 and a 2. Then, or 1 and 3, right? 1 and 4. So this first row tells you that the first die could be landing on a 1, and then you match it up with the second die like that. Let me zoom into that. Okay. Then your second row, obviously the first number is always going to be 2, and then it's a 2 and a 1, a 2 and a 2, a 2 and a 3. I will most likely on a test or a quiz give you this table. You just have to fill it in. And then a 3 and a 1, a 3 and a 2, a 3 and a 3, a 3 and a 4. Then you go on to the next one, a 4 and a 4, sorry, a 4 and a 1, pardon me, 4 and a 2, 4 and a 3, and 4 and 4, like that. This is my outcome table. How many different outcomes do I have? 4 times 4, right? This is 16 outcomes. Let's put this 16 outcomes possible. And you can't see that because I was zooming in, right? So this tells you, you should always just count how many columns are there, how many rows, just multiply them out. That's how many options you have. How many options would you have if you had a 6, like 6 here and 6 there? If it's two standard dice, it would be 6 times 6, right? 36 outcomes. If you had two 10-sided, 10 times 10. What if you had a 6-sided and a 10-sided? 6 times 10, 60. Right? So just keep in mind that this is just a model, and you can like expand. You could have red, blue, yellow, green if it's a spinner and a die, right? So just keep that in mind. So what's the probability, right, of rolling doubles? If I ask you, hey, what's the probability of rolling a double? Double meaning 1, 1, 2, 2, 3, 3, and so forth. And how many doubles do you have? Yes, there's 1, 2, 3, 4. And I'm going to highlight that. If you have one, go for it. I'm just going to highlight doubles there. So you just go by, there are 4 outcomes that you're looking for out of 16 possible. And that reduced, I'm sure you can handle that, 1/4, which is 0.25. It's not always 25%, guys. If you have more, if it's a 6 by 6, then it would be 6 doubles out of 36, right? So don't think it's always 1/4. What about this? Probability of rolling, write this down, okay? Make sure you write this down. Rolling are you ready for this? A sum of 7. What am I talking about there? Mr. Jackson, like, don't do that, right? Don't do that to us, please. Right? What is a sum? An addition, right? This is where I probably will be. I think pencil is fine. Okay, what's 1 and 1? If you roll a 1 and a 1, what's the sum of these two? It's 2. What's the sum of these? 3, 4, fill this in, 5. Then it's 2 and 1 is 3. There's a pattern, by the way. 4, 5, right? Because a 2 and a 3 gives you 5. A 2 and a 4. Have you ever played Settlers of Catan? That board game? Okay, that's one of those where you roll in the sum, like it's the sum of your dice that give you. Anyways, 6, and then 3 and 1 is 4. 3 and 2 is 5. 6, 7. 4 and 1 is 5. 4 and 2 is 6. 7, 8. Now, how many sums? Yeah, go ahead. How many? I thought you were going to answer, Kim J. But anyways, that's okay. What's the sum of 7? How many sums of 7 do you have? There's one right there and one right there. So that would be 2 options out of 16. You could reduce that, right? 2 goes in the top 1 time, goes on the bottom 8 times. Okay, so that's technically the reduced. 1 divided by 8, 0.125, and it's 12.5% chance of rolling a 7. A sum of 7. Keep in mind, you could have a 6 by 6, then everything will change. Okay? Are you ready for this one? The last one I'm going to give you here. Probability of rolling a sum less than 5. Don't do that, Mr. Dirksen. I don't like this. I don't like where this is going. Well, it's stopping there, sort of. Okay. You're writing this down? You want a sum less than 5. A sum less than 5. So less than 5 means, right, less than 5. So there'll be the 4s here. Whoa. Those would be all less than 5. This is also less than 5. And there's another one less than 5. So I just kind of smudged this one out here. So 1, 2, 3, 4, 5, 6, right? 6 instances out of 16. And if I divide both of them by 2, I get 3 over 8. That's probably as good as it gets, which is 0.375, which is 37.5%. So an outcome table is huge when answering dice. Like if you're rolling more than 1, I would say make that outcome table, okay? Which I will probably most likely provide you with anyways, okay? Here's where I want you to go now. I want you to go to page 3 in your workbook. You know which one your workbook is, right? The one that has the deck of cards. And I want you to fill in that table there. Let me just show you what it looks like. You don't have this? You sure? Okay, 1 sec. Page 3, okay, so it looks like this. That is a 6-sided die question, and I'm going to ask you questions based on that. So fill that in. I'll get you one here. Fill it in and I will ask a bunch of questions. Page 3 of your workbook. While you do that, I'm going to add some questions down here. So fill that in. I would do both. I would say do the 1, 1 thing and then the sum, right? So 1, 1, the sum is 2. 1, 2, the sum is 3, and so forth. So Kim J, I don't know if you heard that on page 3, we fill in that table and answer the questions. Probability of getting a sum greater than 9 and rolling doubles. Don't worry about E. I'm not going to make you do E unless you want to do it at home, your own time. Just F and G. And I'll go over this in a bit. Here we go. If you fill this out, I didn't do the actual outcomes, right? The 1, 1, I didn't do that, but I would encourage you to do that. And the one that occurs most often is, of course, 7. Okay, 7 is the most common sum, right? If you were to add it up, so that's there. And then it says, what is the theoretical probability of rolling a sum of 9? And obviously, we're dealing with this, so it would be not. It would be there are 4 9s here, right? So 4 out of 36. If you got 4 out of 36, you're good. Okay, like don't worry so much about reducing it, but it ends up being 0.1111 or 11.11%. Okay, keep in mind you count the number of columns and rows, multiply them, and that's how many outcomes you have. I will test you on that. So it could be 20, it could be 25, it could, right, whatever works. So be mindful of that because the total is right from the table here. That's how many outcomes are there. Okay, possible. Okay, next, I'm not going to do E, so you can cancel that out. You can just scratch it. But probability, this is what I wanted to add. Sum greater than 9, right? What is that? And so just go greater than 9. There's 1, 2, 3, 4, 5, 6, right? It usually goes in a diagonal line. This would be the 9. So you've got 6 options, right? So 6 out of 36, which is 1 out of 6 if you reduce it. And the other one was rolling doubles. And this happens to be the same. Okay, if you did this right, if you go back up here, your doubles are here 1, 1, 2, 2, 3, 3, 4, 4, and so forth, right? So there's 1, 2, 3, 4, 5, 6 options where you roll doubles. So that would also be 6 out of 36, which is 1 out of 6. Okay, happens to be the exact same probability. that's just coincidence. Okay, so it will differ depending on the situation. Okay. Let's go to. I know I'm keeping you engaged right until the end. I hope you're okay with that. Even if you're not, I just want to finish this part. This is basically the end of games, right? We're not playing games anymore. It's serious. Okay, go to page 160. That one I would expect you to know the cards here. The cards, this is on page 160 at the bottom here. Drawing a queen. There are 4 queens out of 52. 2 or a 3. There are 4 2s and there are 4 3s. So that'll be 8 out of 52 to get that. I'm not going to reduce here at all. Red face card. How many red face cards? 6. You remember that, right? 3 and 3. So 6 out of 52. Boom. Done. I just want to make sure we have that. There's 3 hearts and 3 diamonds, right? 3 face cards for hearts and 3 for diamonds. Let's do the dice here. Question 2 and then we're done. What's the theoretical probability? Emphasis on that. The theoretical probability of rolling a sum of 7 with what? 2 standard 6-sided dice. Have we done that just now? We did. Page 3 in workbook, right? And what was that? We had, actually, I'm looking right here, it would be 6, right? 6 out of 36. I will just leave it like that. And then Pascal wanted to compare the theoretical probability to the results of an experiment. Okay, they're mixing it up, right? She rolled 2 dice 50 times, so 50 trials, and got a sum of 7 5 times. Calculate the experimental probability. The experimental probability. How many experiments did she perform? 50. And how many times did it get to what you wanted? Only 5 times, right? 5 trials. Okay, 50 trials and 5 times it worked out. Divide both of them by 5, you get 1 out of 10. How about we do the top here real quick? 1 out of 6, right? And so if dice were rolled 1,000 times, this is your larger sample. How many times do you think a sum of 7 would be rolled? Would you use the theoretical or the experimental? Always use the theoretical. So prediction, if you make a prediction, you use your theoretical times 1,000, and before you go, that is 166.67 times, which is 167 times. Approximately, sorry, I should have used approximately. That's it, that's all. So tomorrow, AC on basically everything we've done so far. Make sure you have your study sheet with the deck of cards on that study sheet. Thank you guys, you were awesome as always.